Hello, I'm Megan Beckley, Program Director for the Electrical and Computer Engineering Department Heads Association and moderator for this webinar on a new concept for wireless debugging presented by Digi-Key and Microelectronica. Before introducing our speakers, I have a quick housekeeping announcement. We will be accepting questions throughout the presentation, which you can submit using the Q&A icon at the bottom of the screen. To access the Q&A box, simply click on the Q&A icon at the bottom of the screen. Now it's my pleasure to introduce YC Wang, Director of Global Academic Programs with Digi-Key, who will get us started today. YC, off to you.
Thank you very much, Megan, and thank you everyone for coming on this webinar. It is my pleasure to present to you as it's my pleasure to welcome you and open this presentation as the Director of the Global Academic Program at Digi-Key. I know probably a lot of you are already Digi-Key customers, so I also like to thank you all for being great customers. And we are very happy to be presenting to you an interesting product and concept for teaching embedded classes remotely to students during, I guess, the current situation. And so, could you move to the next slide, please? Thank you. So this is the agenda for today. We are going to be going over the concepts of how people are currently conducting remote education and wireless debugging. Then we're going to introduce you to a company called Microelectronica, who is a supplier of Digi-Key. We're going to keep this call to conveying a concept across, and also introducing a new product that will support the concept. So we're going to keep the sales side of things light. So, and after that, we'll have a demo by Robert Nelson, who's a principal applications engineer at Digi-Key. And after Robert Nelson demos, then we'll have an orientation of a nifty new product called Planet Debug by Randall Resley. Randall Resley was VP of Applications Engineering at Digi-Key. He is now semi-retired, and he's working with us to develop this concept further, and he's also jointly working with a company called Microelectronica. So next page, please. Instead of throwing a multiple choice poll at everyone on this call, what I've decided is that if you will kindly type into the chat window, and we'll keep this confidential, how you're currently teaching embedded microprocessor and microcontroller coursework, especially when students are remote. How are you conveying concepts across? How are you doing hands-on lab work? I understand that for many of these courses, the ability to work hands-on with hardware is critical to the understanding of the topic at hand. So for a lot of students, how are they doing this right now? Are they doing this remotely? How are they accessing the hardware? How are they debugging the hardware? How are your teaching assistants, or how are you helping the students debug problems? So if you can type into the chat window during the duration of this webinar, you don't have to type right now. We will greatly appreciate it. And again, we will keep whatever you share confidential. We won't share it with anyone else. This is just for our understanding and to see how Digi-Key and also Microelectronica can better support you in the future. Next slide, please. So I'm handing over the presentation to Randall Resley, and thank you very much. And Randall, the stage is yours.
Thank you, YC. And for that matter, if there are any other questions that come up during this presentation, please don't hesitate to type them in, and then we should have time to answer all of them. So with this COVID situation, so many things have changed. Now, this slide on the left-hand slide shows a group of people in a lecture, but likewise, laboratory sessions are typically taught in a room with a bunch of people in it. Today, those lectures are being taught individually in a one-to-one link. And so the question that occurred to us, wondering how can we help universities set up an environment whereby they can get their laboratory experience done in a remote way. Now, when I worked for Digi-Key, one of the suppliers that we had signed was a company out of Eastern Europe, which makes development tools. They are a development tool company. And upon digging into what their products are, it turns out they've got a solution to that, which we're going to walk through. So the other problem with debugging embedded environments is the wiring problem. You always have a rat's nest of wires going to things, and in the future, wouldn't it be nice if I could have all of my I/O tied to a centralized embedded system and have a means of remotely connecting to it? I happen to have one of the setups, which we're going to be demonstrating at my home. Now my home I've got a detached office, so I can be remote from family noises and all of that. And I had the system set up, it was in a wireless mode, and I had to take and go to another part of my building and still needed access to that development hardware. So all I had to do was to pick up a second computer and tie to this central embedded environment that I had set up. And I was able to continue the debugging operation that I was doing in front of the system. And that isn't exactly a new concept. There's another supplier of Digi-Key who has since been acquired by yet another supplier, and that was IDT. And I was surprised on a tour of IDT once, they were talking about how they developed their ASICs by accessing field programmable gate array farms offered by Amazon in their EC2 F1 instance. I think EC is expanded or extended compute environment number 2, and F1 is their FPGA instance. And so with that environment, you're able to access and synthesize debug code. But of course, that's not an embedded environment. Here you're interacting directly with a set of tools running on a PC. The embedded environment is different. There are light indicators and things that you might want to see that don't come up in a console. And so whereas the concept is fundamentally there are other things that have remote debug, it's now possible to do this with embedded electronics. So how does it work? And I'm not sure. I think you can probably see my video. I have in my hands one of the units that's on the screen. And this is an in-circuit debugger. And it has a little adapter board that adapts to a wide variety of microprocessors. It depends on this adapter cable. And then what you're able to do with this end is to plug it into your target board. And this has access to your integrated development environment on your PC via a USB connection. But what's really unique with this is it also happens to have a Wi-Fi connection. And so this all has been available in the last year or so. It's all very new. And the way that Wi-Fi works, if you're inside the network, it makes a discovery of all of the Wi-Fi nodes in there. You could think of it a little bit like your IoT devices that are available through Amazon and Google. So that you can, the units will be found no matter where in the building they are. Then there's also the ability to bridge outside to do a truly remote debug, and that's some of the things we'll be demonstrating later also. So concerns, is this proprietary? Well, the integrated development environment is a proprietary software product of Microelectronica, also known as Micro-E. And this environment is made to run on any platform. It's a Macintosh, it's a Linux, it's a Windows platform. And it ties together the suite of services that one needs to do this remote debug. But they also happen to provide a micro SDK. And what this is a standard by which all of the hardware modules that you might wish to include in an embedded environment are available through packages which have the effect of abstracting the underlying hardware. I'll have more to say about that. Now also the system is built around a clipboard standard, which again also is microelectronica's, but it's broadly available. And I happen to be holding a clipboard. I think Rob's going to be showing some more. They're very small boards. There are hundreds, nearly 1,000 of these little boards available. And so with that standard, students would be able to pick whatever IOs they might need to debug with, and or design their own little boards to plug into their hosts so that they could be doing debug with all manner of sensor, and more than sensor, in fact. So Microelectronica, it's a 20-year-old company. It's growing. It's got scores of employees. It's very engineering focused, and is based in Eastern Europe, in Serbia, close to Belgrade. I think actually might be in Belgrade. And so it is remote. And what's set up there right now is another one of their boards, which is a set of boards that are called fusion boards. And I'm not sure how well this can be seen on the screen here, but they have very many of these set up there in Serbia. And this happens to be with an ST Microelectronica microprocessor on here. And what I'm going to do is connect up one of those boards in Serbia. Now, what YC didn't say, I happen to be on a camping trip right now. And so I'm actually broadcasting to you from a state park in outside of Hershey, Pennsylvania, connected up through a Wi-Fi link. And we're going to show that you can truly do debugging remotely by my connecting up through this little camper trailer all the way over to Eastern Europe. So let's keep our fingers crossed that this works all right. I tested it earlier and it does. Another thing about Microelectronica, how does this work, is it's an entirely vertically integrated company. So they do their own hardware design. They've got electrical engineers. They do their own embedded software design, including compilers. So they've written a variety of compilers with more coming. And then also they've written all their own, the software that they use to run their business is all PC oriented, and they've written that software. So giving them these three perspectives allows them to bring the embedded environment up to the speed of what modern personal computer development is, and enterprise type development. That's how these little embedded boards are able to make a discovery of on a Wi-Fi bus and be found by a PC no matter where in the network those things are. So it's a very complete and thoroughly integrated company. There are scores of suppliers to Digi-Key. These are IC producers mostly, and all of these companies contract with Microelectronica to make these little clipboards, which is why they have, I think on Monday they expect to have 900. They basically come out with a clipboard per day, and a clipboard is essentially the functionality of a chip. So you can basically test something like one of 900 different functions, chips, with a clipboard. Okay, now Planet Debug. We haven't talked about that until now. I mentioned that Necto Studio ties everything together. Basically what it does is it is an integrated development environment so that you can debug and compile your embedded code, but it also has a tie through this networking to a room full or a rack full of those boards that have the microprocessors on them with cameras facing them. Now, this schema, this system is called Planet Debug. And so basically, I can make a one-to-one connection from my locally installed Necto Studio instance to this debug environment, no matter where it is in the world, and actually see that board, because Planet Debug, or I should say Necto Studio, ties all this together. Now, the universities have the opportunity of establishing their own Planet Debug. But one of the things that Microelectronica is making available, and it's available to all of you, is to put whatever clipboards are desired onto a host microprocessor board to enable students to schedule time and access and actually debug that hardware on microelectronica's setup. That's known as a hardware as a service capability and is a direction that microelectronica is going. So on one hand, your students can build their own micro boards. They can, I should say micro bus boards. They can put them on carrier boards that have access to Necto Studio. That can be at a university level, could be at a student level, a university level, or the university doesn't have to buy any of that and simply get access to this capability that's provided by microelectronica in their Planet Debug rack farm of development boards, and they'll configure those boards plugging in whichever ones you want. Okay, hopefully there's some questions coming in here. Now, a lot of people know Arduino, and it is an incredibly popular and very, it's made a lot of people interested in electronics. It's reduced the complexity interface to design something new. And I like to think of these clickboards as an alternative to those. Again, with an Arduino, there are a set of boards, but there's no larger a set of I/O boards than is available in this microbus standard. And so and the other thing is that for electrical engineering, whereas the Arduino hides a lot of the underlying details, I don't have to get into configuring a linker command file or anything like that. The micro SDK obscures or covers up that lower level detail of the boards for students so that it's not quite as encumbering. But likewise, you have access to that lower level. So you can get to a hardware accelerated level or attack everything from a higher level. So it's basically a broader platform with more options. So it should be, I think, better for, say, the electrical engineering student than an Arduino. The fact is the microprocessors, and there are hundreds of microprocessors supported in this ecosystem that microelectronica has set up. Some of those things are very much more powerful than the Atmel instruction set architecture of Arduino. That's nothing against Arduino, it's just that it doesn't solve all of the problems. It doesn't have as many options as this alternative that we're presenting has. As I said too, microelectronica, they write their own compilers. AI stands for Advanced Integration. It's the compiler that's built into the Necto Studio. They've got BASIC, they've got Pascal. There are more compilers coming online, C++, Python. So it's a very robust compute platform. Your students can use pretty much whatever language you would like them to. If you want to learn more, and I'm just going to try this, I'm going to click this link, if I can get back to it here. And this should pop up the microelectronica site. Micro E is what they go by. I'm just going to click on this 900th clickboard coming. And upon clicking on that on the home page, I'm going to scroll down. And you can see they talk more about what the clickboard is. And they talk about it's got a universal interface. And that standard can be downloaded simply by clicking on that microbus standard. All of these boards are standard form factor, but they've got 3 variations to it. And with the number of boards, again, you can configure just about any system that you'd want to build. So these boards are separated by direct name of the board, but likewise, they're grouped by categories of boards. So I can choose my wireless, my storage, my sensors to find these things. Another thing that they have is this libstock or livestock. This is on their website. You can click to it, and there you can, upon finding one of those clickboards, you can download the package for that board so that you can then be running a demonstration with that board as easily as possible. And then the micro SDK, which I mentioned, that specification is written right here. You can click on that. There's a cloud solution that's available, but that's more for IoT. And again, all of their partners. So let me switch back to the presentation. So what I'm going to be doing next is to turn it over to Rob Nelson, who's going to give an orientation of that Necto Studio integrated development environment. And then he's going to give a demonstration building an actual project. Then we'll come back to me and I'll show you this Planet Debug, and then we'll open it up for questions. So Rob, let me turn it over to you. I'm going to stop sharing my screen, and then you'll have it, hopefully.
Thanks, Randall. As I just move this over to the screen, there we go. We should be live. And it is on the other screen. So this
looks very clear to me, Rob. You're looking good.
Perfect. So Randall brought up Arduino. So here's an Arduino board with the click header. So there's plenty of options for everyone to switch back and forth. I mean, the click standard is pretty much every dev board out there today has it. So we're just showing that like almost everyone does it. So now we'll go back into Necto Studio. So this is Necto Studio, the new IDE. We've got the initial welcome screen. All their help information is embedded in here, so you can quickly go and see tutorials, language specs, and everything. So all their, they keep, as they add a click, they also add drivers and libraries. So for example, today, if you look at the picture of the board again, we have a weather click, a UV click, and air quality. We're just going to add the weather click really quick. So we're going to go to Browse and look up the weather. So here's a weather click. I have it installed. So what we're going to do is basically create a project with that. So go back to the welcome, examples, and weather. That wasn't installed. Let's delete it and then re-add it. I've been messing around with editing and adding projects, so. Examples, and then we want the weather. Sorry, I was pre-testing things before this lecture. And actually examples, weather. And so what I'm going to do is actually going to swap out this. This is the UV one. I'm going to close this for a second. Don't you love how you start a demo before a demo and you break everything?
Yeah, for sure. But basically what Rob was doing is in the environment, it shows up and it shows all of the clipboards that are available. And then all one has to do is to click on one of those, and then one can download and install that package. So you can browse through what you might want to use, click on it, install it, and then that's going to build the hooks into Necto Studio so that you can bind to it with your compiler. And also, too, let me mention, I do see there are questions and there are chats coming in, and we're going to answer every one of those. So, Rob, I'll turn it back over to you.
Sure. Thanks, Randy. Yeah, simple restart is now working again. So when you select one of these UV click or weather, it'll actually pop up what we want to install. So we're using micro SDK for the build, but you can also do the old compatibility. And next, the board will pop up. We went to Fusion for ARM because that's the one we have. And now it'll just take a moment.
And in the process of going through and what it's basically going to do is to build the environment, build that package in micro SDK for whatever microprocessor Rob or anybody will have checked. And again, there are hundreds of microprocessors supported with this platform. So the Fusion board that he shows there is the base platform. That base platform has buttons for user input. It's got headers for making fly and wire connections to other systems, and it's got these clipboard sockets. Now, I mentioned that code grip earlier on. built onto this Fusion board that Rob's using is an integrated code grip. So he's able to make either a USB or Wi-Fi connection to his board there. Okay, I think you're back there, Rob.
Yeah, and I've completely hosed the system. I might have to reboot. There's something completely wrong with my Windows 10 right now.
And I might be able to take over for you here.
Gee, let's just try the air quality one too. Quality click. We're going to add.
So these are clipboards that Rob has on hand.
Yep, so these are the ones that I have right here in this board. And you can actually see the old demo still running in the corner. So this is the air quality click on number 3. But I've somehow hosed something, and so let's try the air quality again, MicroSDK 2.0, and this should show the full list of boards, and that's not good.
One more, and as usually you can choose those. Yeah. And it's hanging right there. Okay.
I'm just going to reboot really quick, so I'll be right back, you guys.
Sure. And so I'm going to go ahead and go back and share my screen, and hopefully you can see my environment. So when you power on, a welcome screen comes up, and what it's doing is it's surfacing a bunch of examples. Now I can search for an example by typing it in here, and I've already installed and run this ADC version 9 clipboard along with an SHT. That's a temperature and humidity sensor from Sensorion. So if I wanted to add, I'm just looking through here, I can scroll down, LED curtain, let's say I want to make use of this UART. If I click on that, it opens it up as the as that code, so I can then go ahead and build it and run it. But I want to go back to this. So it's here on the examples that I can download and get familiar with this environment just by clicking in and running it. But likewise, it will show you what the recent projects that you've run. So when you come back to the environment, once you've chosen one, it comes back in this recent environment. And then you can get news on from the Microelectronica website and all. Now, on the left-hand side, I can edit the code that comes with the project, the one that I'm starting. I can newly create a project over here. This edit project allows me to edit. Is this for a micro SDK? Is it for a standalone package? This allows me to configure that, and Rob will show you that. And then these packages are also and then what Rob was on was the installed. So you can see I've got those two clipboards in my project. So it shows installed. But again, if I want to pick a different one, let me just take this one and I install it. Let's see if on my system it works all right. Notice it's downloading that package. So now that's built into my environment that I can make access to it, which I'll show. Going on here is, and I think actually Rob will show it. I've got different licenses. Now, there might be some questions as to what is the cost for the license, and we can get to that. And then down here on help is where all of the instructions for setting this up are, including tutorials and the rest. Okay, now Rob, are you back?
Yep, I'm back. Hopefully.
Let me stop sharing.
So we'll share screen. Yeah, sorry about that. I just rebooted my computer, everyone, so I think we're in good shape now. So we have Necto Studio. It's showing up on my live stream. We've added that, so go back to here, click on this, micro SDK, next, Fusion for ARM, and it's going to lock up again. Yep, I hosed something up on this machine.
So there's some questions online that I'm going to answer. So what are the different, and my son asked me this actually. Now my son's a veterinarian, but he plays around a lot with electronics. But the question was that my son asked, that's being asked here, is why not just do a simulation? Why do it on the hardware? And what it amounts to is it is many, many times faster in hardware, and you can access actual devices. So in the case of my son, he wanted to measure the tracheal pressure of a bulldog. And so in order to get that data, he needed to be tied to something. And so doing this on actual hardware allows you to be measuring real signals. Now, sure enough, doing a simulation is a great way to go. When I worked for Texas Instruments, we were involved in active suspension systems on automobiles, and the comment was made that no engineer would trust the simulation when your life depends on it. And the comeback was, well, I can't drive my car over a curb that's 3 feet high. In other words, you can stress the system much more than you'd see in real life. And that's true. So both of them, both simulation and real-time debug, have their own places. But this is the first time that I'm aware of that you can actually access real-world signals from anywhere in the world on a debug hardware environment and debug single step, step over, step in, step out, do all of those functions that you'd normally be able to do on a PC, except on a development environment. So, Rob, did you have anything to add or comment?
Nope, that was pretty good writing. I just
switched
the computers over, so let's get this a shot.
I'm going to go on and demonstrate while and let's see, am I sharing my screen? No, I'm not. Let me share my screen again. Okay, so now I'm back in, you can hopefully see my Necto Studio, and I'm going to come over to this Edit Project button. And again, I can determine what my tool chain is and what I'm compiling for, which SDK am I using, what microprocessor, so forth and so on. But on this right-hand side, so I've got my project manager. If I right click, I can manage the libraries, and this would be where I'd add in on different clipboards libraries. I can go over to my debug window, and if I'm attached with Wi-Fi or USB, that would be a local setting. I can do a code explorer to see all the functions and variables in my code. So I've got all of these standard functionality, but this last button is Planet Debug. So again, I'm here remote in Hershey, Pennsylvania, and as you scroll through here, these are all of the boards that are available on online right now in Serbia. Now, one of them here is busy, so someone is connected to it, but these would be you could reserve these for students to access. You could schedule their time, and then you could track whether or not they're actually going and debugging. How much time did they spend on the project? I'm going to go ahead and I happen to have a local copy of this STM32. It's the F407ZG board, and you can see the clipboards that are on this. I'm going to click go, and as soon as this comes up, again, this is right now making access from my local laptop over to Eastern Europe. I'm going to pull my screen open so that when this comes live, now there's a whole lot going on here. We're talking on Zoom, we've got video going, and I can see this is coming up. What we're looking at right here is that clipboard. And so in this situation, I can go ahead and be debugging on the left-hand side, writing my code, and download it directly to this board. Now, so that someone doesn't monopolize this time, there's a timer. And so one applies and gets a license for how much time, how much access do they get to this board. The platform continues to evolve. The setup and rig that Microelectronica has set up, you could also set up it in a closed university environment, but it is awesome that you have complete access to this. So that is Planet Debug. Now, I've got another question, and that is whether or not we can open up all microphones, unmute everyone, and take questions that way, or whether we have to take them typed in. Megan, can you comment? Are we able to take audio questions, or do we have to go through the chat and Q&A?
We are able to take audio questions. If people do raise their hand, we can allow them to unmute.
Okay, great. And then can you moderate the participants that are raising their hand?
Yeah, absolutely.
So I've opened up some of these. I've got a question here from Jonathan. It's difficult to, with embedded systems. Oh, okay. This is an answer of the first question, the YC. And YC, are you available? You still on?
Yes, I am. Yes.
And the Micro E team, the microelectronica team, are any of you online? You might have to raise your hand in order to be recognized in order to speak. But one of the questions that Alvin asks is, when will C++ be available? And I've been told that that's currently in development, so I'd expect that in a matter of months. But I'd like for someone from Microelectronica to confirm.
Hello,
Yes.
this is Ivan Kovic from Belgrade, and concerning the C++, it's actually wider thing. It's CMake support in Nectar Studio. So basically with the CMake, we will get not only C++, but access to GCC and Clang also, and all other languages that will be. So we are about planning that to be realized somewhere mid next year. So it's months, but not months in terms of 2 or 3 months, more like the summer of 2021.
Okay. And so you said Ivan, yes? Ivan?
Yeah.
Yeah,
Yes, yes.
and so you're using CMake, you're using standard Windows tools. Now, I mentioned before that you also do your own compilers. And so let me ask you, is this environment based on open source tools like GCC, or is it your own?
Well, this is a completely open environment in terms that it will support our own tools, and in the future we will support GCC and Microsoft compilers. So basically, you can use Nectar Studio. That's at least our plan to with any compiler or any tool chain that you like to, and any build system. So idea is not to compete, but to bring the value to the table. So not to tie you in some vertical structure of our company, but just as maybe it's not clear, but Nectar Studio as a software project, as IDE is currently free of charge. So basically you can use Nectar Studio completely free of charge. So the only thing that we are currently charging is our compilers. So basically, if you're using Nectar Studio with some other compiler, it's completely different story. But the most important thing is that adding C++ and Python and any other language will be rather easy. So it's something like Visual Code if you like to think in terms of what are the capabilities or future capabilities of this product. At least how we see it.
I see. Another question here is, the question was, are we saying that the full line of Arduino boards is available as components of the Micro E boards? And that is not the case. The Arduino platform is separate from the Click board, the microelectronica platform, but a lot of those functionalities are duplicated. One thing that might be considered a little bit different is that in the case of the Click boards, you're able to buy them essentially in single functions, whereas the Arduino, there might be some boards that have a broader complement of functionality. And if you need all of that functionality, that's a good way to go for sure. But in the case of clickboards, it's more granular, and it's also very robust mechanically, so that you can have a motherboard holding these clickboards, and it's a very robust platform. But they are different platforms. You can get an adapter that goes from Arduino to Click, but I'm unaware of any boards that are exactly Arduino copies in the clickboard form factor. Again, the clickboard has this microbus, which utilizes a PWM, an analog in, an I2C, a SPI bus. So it's got some prescribed interfaces to these chips that it uses. It isn't the full an Arduino interface. how do you click on a clipboard that's remote? So right now we have visibility of those boards on the clipboards, but the capability to be able to push on the image and toggle the switch, I'm unaware of that being available. And with Ivan on the line here, he may not like answering this, but are there any plans to make the video portion interactive so that somebody can click on a button in the video? If you're talking, that is, you're on mute. So I don't know the answer to that. Another question is when I, oh, okay, you're back. All right.
I'm here. So there is the plan. Sorry for that. It was just technical issue with unmuting. So basically the plan is also to make possibility to have actuators and have possibility to interact with, not only to have visual of the boards and be able to test the boards that don't need actuators, but to add actuators. And so it's one of the, let's say, phase 2 or phase 3, depends how all these things going, but we definitely have in mind that you have to have access to buttons, access to sliders, access to touch panel of TFT and so on. So there is currently planned to see how is the best approach to get that working. Is it to connect with the code grip, which is programmer debugger, and to use it to make those gestures from the user on the PC, on the real hardware, or something less. We will see, but that's the plan. So that's also in the pipeline.
So this is YC here from Digi-Key. I also want to add something to this, because it seems to me that the question is basically it's envisioned that the hardware in this case is remote, and there wouldn't be a way for people to push the button. So the goal of today's presentation is to showcase the fact that there's a product called CodeGrip, and CodeGrip works with an IDE called Necto. So it goes both ways actually. So there was actually another question in the chat window. Basically, if we're able to ship an MCU and a debugger to each student, is there a benefit to the CodeGrip system? Would this just be for the consistency of setup? So to answer both of this is, you can see CodeGrip going both ways. Okay, what Rando is showing on the screen right now is CodeGrip running on a Fusion board that is very remote from him. Okay, so you can envision this situation as if the university has set up an array of these boards, each one having a different set of hardware for students to try. That means I'm going to teach you how to access a certain peripheral. I'm going to teach you how to read a certain register, and the LED can be blinked and is viewed on the camera as an exercise. This is if the board is remote. So this is for the scenario where if you're having problems getting hardware out to students remotely, and they still have to run embedded exercises, then maybe the university can set up pre-set up hardware arrays for them to play with remotely. That's one scenario. The other scenario where you saw Rando showing the CodeGrip pod at the beginning of this presentation. Now, that scenario is where if you get the CodeGrip pod out to students who are remote, then in that case, if they run into problems, your TA or you can access their board from your Necto Studio to their board remotely. So you actually have the capability of drilling in to the register level on the board that they're running to help them debug, as opposed to saying, okay, on the phone, push this button now. What happened? All right, let's redo this again, right? Debugging remotely. Now you have the ability to actually interact with the student's hardware on their desk when they're remote. So it goes both ways. It can either be from a centralized university location where you have multiple microelectronica arrays set up for trying different embedded applications, or for touching or playing with a student's board on his desk at when he calls in and says, "Hey, Professor so and so, I'm running into problems." You can literally tell him, "Turn on Necto, connect your board. I want to take a look," and that will allow you to have visibility that you normally wouldn't have. So, but anyway, very good questions. Sorry, Rando, of hijacking this, but I think
No,
this
no,
will
no. I think you
answer
did good.
Right.
Yeah,
Okay.
and then you also answered the question, if I have custom hardware, if my only option to use Planet Debug, and the answer to that is no. You can just use the parts and access your custom hardware, but still have this ubiquitous access to it because the microelectronica team has supported things with an internet protocol that happens to be also on Wi-Fi. I want to come back to the simulation question, just to be clear. So simulation is a great thing to do. It's orders of magnitude slower in performance. It does have some advantages that I can feed signals that are not real world into a system to see what my code does. But this environment is not that. This is an environment where in the past you would be tied with a JTAG interface to your own hardware. This allows that, but then also provides access to hardware that can be anywhere else in the world. So it is not a simulation environment. It is an emulation and development tool environment. Let's see, another question was, when you showed the board you are using in Serbia, okay, so that's on screen. Are you also using that code grip device on your PC in Hershey? And so I happen to have, working a little bit here for microelectronica, they've provided me with a fusion board, which they put in their Planet Debug racks. And likewise, they've provided me a code grip. Now, this little board right here is the code grip functionality built onto it. And so I could be connected entirely local with my hardware, but I don't have to be connected that way. Having this hardware here just provided me a means of getting familiar with the platform and all, but I can also do that online. The only issue with online, of course, is that you're competing with the world in access to this. And so being able to reserve access, today there are, I don't know, I think there are around 20 or it might be 30 of these boards available at any given time. Eventually, microelectronica would hope that this catches on enough that they would provide 1,000 of these boards that could be connected to support that many more people, 24 hours around the clock. So basically, I just have this local version in order to play it around with the environment. The environment is local and remote. Okay, I think that answered all the questions, and we'd very much welcome any other questions.
So,
Yeah.
Rando, in the chat window, there's another question from Ilya. Sorry if I mauled the name, but would a viable setup be to have one code grip hooked up to custom hardware at my house, perhaps several such setups, a student connect to my hardware via internet?
Absolutely. Absolutely. So each one of those code grips has its own address. You would set that up so that there could be unique access. Now, some of that networking configuration, you may end up having to take responsibility yourself. Right, static IP addresses, port forwarding behind your firewall, there's likely to be some need for setup. Whereas if you use an online version, and we haven't even asked the question of whether or not you could send that custom hardware to microelectronica and let them host it. That's a whole nother matter, but I suspect anything is possible. But yes, you should be able to set up having a wireless debugger on each one of your custom hardware. Anybody can access this as long as they have their own instance of Necto Studio tied up, and you've given them the connectivity, the security keywords that once found, a secure connection can be established. Once they have that, anybody can access your hardware. That was a great question. And that'd be an awesome way of, one thing you could do with this, I've always thought of, it's too bad that so many labs start off fresh. And so much of that has to do with the student having to come up to speed. He's got to start from a simple level. But on another level, it'd be so neat to be able to add on top of what a previous class has done. And I think that with this setup, we begin to get into that, because that hardware doesn't have to be in one place. It can be connected up. So, and I haven't seen, are there any other questions that have come in, YC or Rob?
Not yet, but again, I highly recommend you to type the questions into the Q&A window, not the chat window, so it's easier for us to monitor. Something I want to add is that when you look at that screen, okay, right under the Micro E logo, that's where the processor board sits. That's where the processor daughter board sits. Right now, I believe that is an ST Micro device, if my screen is clear enough.
It is. That's the STM32.
Right, that's modular. So
that's right.
And so if you look at the name of this board, it's a Fusion for ARM V8. So Microelectronica has a vast array of ARM daughter boards that will fit on here. So it's more than just the peripheral and the accessories that's modular. You can switch out processor boards as well. So let's say you want to switch away from your current vendor to a different brand. This board gives you the capability to do that, or similar boards from Microelectronica. This one in particular is for ARM, but they have one for PIC processors, and they have one for many others. So,
Yeah.
And in addition to that, something I want to mention is Microelectronica have smaller boards. I think they're called flip and clicks. They're smaller boards, and they allow you to have a setup with a smaller footprint and also lower cost as well. Okay,
but these are the most flexible boards. The one you're looking at right here is one of the most flexible. And again, there are hundreds of CPU cards that fit. So this is a Fusion for ARM. There's a Fusion for PIC, in which case there are multiple PIC boards. There is a continual evolution of these boards, and all of these are available through Digi-Key. Some of these are in stock, have their part number, but there's also known as a non-catalog part. And you can order those also from Digi-Key, in which case Digi-Key will place an order with Microelectronica to get whatever board Microelectronica offers. And the only consequence to that is it's not going to be an overnight shipment, because it'll have to be received by Digi-Key and then sent out. So a whole lot of these things are available from Digi-Key. And I suspect that every one of those 900 boards is. I've not checked, but one of the questions was, are these available from the online catalog? And generally, yes, but practically, it's not all of the boards.
So something I want to add to this is, at the very beginning of this presentation on the agenda page, I actually took a snippet of our Code Grip Central page. That is everything related to Code Grip from Microelectronica. And so we can share the link to that page with all the attendees at the end of this presentation. But you can basically, it's a one-stop location for you to browse through all the possible clipboards, Code Grip, and also Fusion for ARM platforms. Fusion platforms that will allow remote debugging to happen. So we will send the link out at the end of the presentation. So yes, it's all in our catalog, and I will say most of them are in stock right now. And also a call out to Rob Nelson on the wonderful work for the BeagleBone community.
Yes, Rob is well known in Linux and in BeagleBone. That's what makes him a principal engineer at Digi-Key.
Okay, perfect. Are there any other questions?
Or housekeeping. Megan, is there anything else that we are overlooking?
I think that's it, unless we have any additional questions.
So, perfect then. I appreciate everyone for coming onto this call. And we are very happy to introduce, again, this is introducing a concept that's enabled by CodeGrip, which is a relatively new piece of hardware. And what I would really love to see is eventually, you know, visiting a university campus when this whole thing blows over, is that I'll be able to see labs with CodeGrip that students can access remotely, or students coming up to me saying, "Hey, I worked on a microcontroller project, and I was able to get through with this remotely with CodeGrip." I think this is perfect for essentially remote collaboration. Again, it can be the university hosting the hardware, or it can be students running a session that the professors and everyone else can access. So essentially, this is, you know, the enablement of remote collaboration. And to my knowledge, this is one of the first such products being offered in the industry that does this now. So, um, anything else you want to add, Rando or Rob?
No, just thank you very much for the opportunity to showcase this new capability and hardware, and I look forward to doing it again. And also, too, if anybody has any questions, please ask them. You know, Rob Nelson is available through the Apps Engineering, the technical support line. I don't know the best way to contact, maybe just through ECETA, but we will follow up on any questions that we get.
And there's one more question. Are the slides going to be available? And the answer is yes.
Sure.
And normally at the end of an ECETA presentation, we will send out a thank you email to all the attendees with all the pertinent links, and also the slides and things we have demoed during the presentation.
Excellent.
Okay.
Thank you, YC. Thank you, Rob.
And thank you very much to all the attendees who came on this call today. And I see that we have a very steady number holding throughout the call. Right now it's dropping because people are hopping off. But I thank you very much for sticking all the way through, and have a wonderful weekend.